this is worksheet 2 of the equations packet. It's the first worksheet that we have a video for, and it's going to be in 2 parts. So when you finish watching part 1 here, you're going to need to go back to my website and also watch part 2 of this video. So, you want to underline, or better yet, if you have one, highlight what I have highlighted, and you're going to want to write everything that I write. And you will have a brief quiz when you get to class, just making sure that you have watched the video and paid attention. It's not a quiz that's meant to be hard or tricky, but just to hold you accountable for watching the videos so that you know what's going on when you get to class tomorrow. So, we have already learned prior to this in Chem A that symbols represent elements, right? So like Na represents sodium, or Cl would represent chlorine, Mg magnesium. And we have learned that formulas represent compounds or combinations of elements, right? So MgCl2, that's a formula that represents magnesium chloride. So now we are going to take this one step further, and we are going to write equations, chemical equations, that represent chemical reactions. So what happens when you combine multiple compounds? So if we look at an example down here, you can start off with this reactant, so I'll put an R for reactant, right? That's what we start with, is called a reactant, and this other reactant here. And if you combine them together, a chemical reaction will occur, which means that we are going to rearrange the combinations of atoms here. But we are still going to follow the law of conservation of matter. So we are not going to create anything new that wasn't there to begin with, and we're not going to destroy anything. So the atoms that we start with will still show up as products. They just might be attached to different things. So if we look at our products over here, right, there's Ba. Well, look, Ba was a reactant too. There's SO4. Well, look, SO4 was a reactant too. It didn't just miraculously appear. There's a hydrogen. Look, hydrogen was a reactant. NO3, nitrate, right? Well, nitrate was also a reactant. So we have not created anything. We've just rearranged, kind of like shuffling a deck of cards rearranges the cards, but doesn't change the number or type of cards present, right? Unless you're playing with somebody who's pulling one over on you. So we can see, for example, that in the beginning of our example reaction, right, we have barium, so you want to write this, nitrate, that's the BaNO3 too, so barium and nitrate are combined, and we also have sulfuric acid. Gotta think back to Chem A to remember how we named acids. So we have sulfuric acid, a hydrogen and a sulfate combined. This arrow here is read as yields or produces, and it separates our reactants that are on the left from our products that are on the right. So when we look at our products, you can see we've rearranged things. Now barium is combining with the sulfate instead of the nitrate, and the nitrate is combining with the hydrogen, right, instead of the hydrogen combining with the sulfate, and that forms nitric acid. All right, so your job when you get to class tomorrow is to fill in the examples that we have not yet filled in. So you can work with classmates on that. But to get down to the real focus of the lesson today, there are 4 categories of reactions. So anytime we look at a reaction, we should be able to put it in one of 4 groups. a composition reaction, which we'll abbreviate with a C, decomposition, D, single replacement, SR, or double replacement, DR. So, what you want to work towards by the time we get to worksheet 3 is to be able to look at a chemical reaction and tell me which category it belongs in. So, in a composition reaction, right, I think of composition as meaning combination, right? The words kind of sound similar. Or some people think of this as the marriage reaction. How sweet. Because you start off with two small pieces, right? In this case, two elements, Na and S. And they combine or marry to form one thing. In this case, Na2S. So we start off with two reactants, sodium and sulfur. And we end with one product, sodium sulfide. Okay? So in our other example that you're going to fill in when you get to class, this time it's not single elements, but it's still smaller pieces combining into something large. So we have water, which is a relatively small molecule, and sulfur dioxide, another relatively small molecule, combining to form sulfurous acid. All right? Okay. Next type of reaction, a decomposition reaction. Okay, so while composition was the marriage reaction, this is the divorce reaction. So decomposition, divorce. Some of you guys also know that to decompose means to break down or break apart. Okay, so really decomposition reactions are just the opposite of a composition reaction. You start off with one big piece or a large compound, and it's going to break apart into two, or every once in a while more than two, smaller pieces. Okay, so in this case, our reactant is aluminum oxide, and it is going to yield, right, because that's what my arrow means, produce or yield, aluminum and oxygen. Okay, in our other example, again, a big piece, the carbonic acid, is going to break apart into water and carbon dioxide. But you'll work on getting that filled in when you get into class. For now, what I need you to do is open up part 2 of worksheet 2. You are responsible for both parts before you get to class tomorrow.